Software reengineering follows a systematic process to transform an existing system into a more maintainable and improved version. The first step is deciding what needs to be reengineered. Sometimes the organizations re-engineer the entire software system, while in other cases only specific modules or you can say components are selected. For example, a company may only modernize the payment module of an e-commerce platform instead of rebuilding the complete system. The next step is reverse engineering. In this phase, developers analyze the existing software to understand its functionality, architecture, design, and behavior. The goal is to recover knowledge about how the current system works, especially when the documentation is missing or outdated. After understanding the system, the source code restructuring may be performed if needed, and this involves improving the internal structure of the code without changing its functionality. For example, an old procedural system may be transformed into an object-oriented design to improve modularity and maintainability. The process may also include data restructuring, and over time, databases and data formats may become inefficient or inconsistent. Reengineering can recognize database structures, remove the redundancy, and improve the data management. Finally, forward engineering is applied to build the improved version of the system. Using the recovered understanding and redesigned structure, developers implement a clean and more maintainable and a modernized software system. Now let's understand the figure shown here. The left side of the figure represents the existing system. At the bottom is the implementation level, which is the actual source code, and above that is the design level, then requirements, and finally the conceptual level, which represents high-level business understanding and system goals. The upward direction on the left side represents reverse engineering. Here the developers move from low-level implementation detail towards upward high-level abstraction. In simple terms, they analyze the code to recover the design, requirements, and conceptual understanding of the system. At the center of the diagram is alteration. This represents the changes and improvements made during re-engineering. These changes may involve rethinking business concepts, re-specifying the requirements. These changes may involve rethinking the business concepts, re-specifying the requirements, redesigning the system structure, or rewriting parts of the code. The right side represents the target system, the improved version of the software. Here, forward engineering takes place. Developers move downward from conceptual understanding towards implementation. They refine requirements, create improved designs, and fully generate the new implementation. At the bottom, the diagram shows a comparison between the existing system and the targeted system in terms of functionality and quality. The goal of re-engineering is usually to preserve or improve the functionality while significantly improving the software quality, maintainability, and structure. So overall, this diagram shows how software re-engineering combines reverse engineering, alteration, and forward engineering to transform an old system into a better and more maintainable one. Now let's have a quick quiz. Scenario 1 says, which statement best describes the reverse engineering in software re-engineering? So options are writing new code for the improved design, converting requirements into the design models, analyze existing code to recover system knowledge, or removing the redundancy from database structures. So the correct answer is C. Reverse engineering is the process of going from implementation back to high-level understanding. It means studying existing source code to extract the system design, architecture, requirements, and the conceptual knowledge. It doesn't involve changing or improving the system. It involves only understanding it. Next, which of the following is not directly changed during source code restructuring? Your internal code structure, functionality, readability of code, or modularity of a system. The correct answer is B. So source code restructuring basically improves the structure, readability, and modularity, but it doesn't change functionality as we discussed just earlier. So if functionality changes, it is no longer restructuring. In the re-engineering process diagram, the center region, that is alteration, primarily represents what thing? So here are the options: execution of program code, transition between the understanding and rebuilding, database normalization, or final deployment of a system? So the correct answer is B. The center alteration phase is the bridge between reverse engineering, that is focused on understanding the old system, and forward engineering, that is focused on building new systems. So it includes redesign decisions, requirement refinement, structural improvement. So it is not execution, database only work, or deployment. Next, which sequence correctly represents software re-engineering flow? So here you can see these options. The correct sequence in software engineering starts with reverse engineering, where we understand the old system. Then comes alteration, where improvements are made. And finally, forward engineering, that builds the new system. So the correct answer is B.